All right, we're going to roll through review 5 here. Number 1, make sure we're reading this information carefully here because of the way that they label A, B, C, and X, Y, Z. We can easily tell the corresponding parts. A corresponds to X, B corresponds to Y, C corresponds to Z. AB corresponds to X, Y. Just go in order, okay? So it's going to be A and X. A and X is going to be the answer for this one here. All right. Number 2 in the diagram, AB is congruent to DE, and then angle A is congruent to angle D, and then angle B is congruent to angle E. So which method can be used to prove? Well, simply angle side angle. Okay, so there it is. Boom. That's pretty easy, right? Which statement is sufficient evidence, that means enough evidence, that DEF is congruent to ABC? So there is a sequence of rigid motions that maps point A onto point D. So A onto D, AB onto DE, and angle B onto angle E. Okay, is that enough information to say that they are congruent? Well, not necessarily, because they didn't say angle A was congruent to angle D. They just said point A is mapped onto point D. If they would have said the angles were congruent, then we could say that. So that's not it. That's not enough information. How about there is a sequence of rigid motions that maps AB onto DE. AB onto DE. In the rigid motions, that means the distance remains the same. They're just reflections, rotations, translations. Nothing gets bigger or smaller. So sequence of rigid motions is basically telling you congruent. BC onto EF, BC onto EF, and AC onto DF. And there it is. See, because it mapped each side onto another side, a corresponding side, it's side, side, side. So there it is. That's enough information right there. Choice C talks about the angles. Angle, angle, angle is not enough. All right, and then just giving two sides, two pairs of sides, that's not enough. You need side, angle, side, or you need 3. All right, so we knew that was not enough. So it is choice B that would be sufficient evidence. Number 4 here. There's a lot going on here. Which one of the following statements is true? All right, so we got to use what we know here. We know vertical angles, so we know intersecting lines. We know this is going to be 68 degrees right here because of the vertical angles. We know this is going to be 122. Okay, we know this is going to be 78, and we know this is going to be 112 right here. So that's just with vertical angles. That's all I did there. In a picture like this, I try to label all the angles that I know. Also, linear pairs, when you have a straight, that straight line there, you got a 180, so you got a 180 right there. Okay, so then this must be 180 minus 68. 180 minus 68, and that's going to be what? 1012. 1012. All right, so that's going to be 112. All right, so this is 112. Now this one here is going to be 180 minus 122, so that's going to be 58. So this is 58, which means this one's 58. And then this here is going to be 180 minus 78, which is going to be 102. And so this is 102. And then this is 112 and 68. So the ones that match, see how it's 112 and 68? And then you got 112 and 68? The ones that match must be parallel. Those lines must be parallel. Okay? So we could tell that L is parallel to P. L is parallel to P, and that's choice A. All right, because you got to have those corresponding angles congruent, the corresponding or the alternate interior. If you just totally ignore all this nonsense, look at 2 parallel lines cut by that transversal right there. Okay, and you got the alternate interior angles, 68, 68. That's another way to look at it. In the diagram below, ABCD is a parallelogram. That's important because I know opposite sides are congruent. I know opposite angles are congruent, stuff like that. That's a parallelogram, so I have opposite angles congruent. All right, this angle is congruent to this angle. if CE is a congruent to BE, all right, so let's do this. CE is congruent to BE. Oh, BE. CE is congruent to BE, okay? And I know DA is congruent to CB. All right. What is the measure of angle E? So what's the measure of angle E? All right. So what do I know here? I know angle D is 112. I better put that in. So I know this is 112 right here because I know opposite angles are congruent in a parallelogram. So I know this angle right here. I know this angle right here is 68. All right, 68. That's a 180 right there, right? Okay. So we have 112 and we have 68. Now, this is congruent to this. So see this triangle BCE? That's an isosceles triangle. If this side is congruent to this side, then this angle is congruent to this angle, which means this must be 68. And if those are both 68, that's 136. They add up to 136. Angle E must be whatever's left over because three angles of a triangle add up to 180. So we're going to do 180 minus 136. And that's going to give me 44. Okay, so that's going to be 44. So it's going to be choice D on that one there. So number 5 is choice D. Quadrilateral ABCD has diagonals AC and BD. Which information is not sufficient to prove it's a parallelogram? So not sufficient to prove it's a parallelogram. All right, so let's say it was a parallelogram. Okay. Kind of. All right, so we got A, B, C, D. All right, diagonals AC and BD. Which one is not information that would prove it's a parallelogram? AC and BD bisect each other. This is true for a parallelogram. So that would be enough information to prove, okay? AB congruent to CD and BC parallel. Okay, well that's true, but that's not enough information right there. You have to have the same side. If this was congruent and also parallel, if we knew AB and DC were parallel, like this is true right here, that's enough information. And then AB congruent to CD and BC congruent to AD, opposite sides congruent, okay? Opposite sides congruent would be enough information. That's true, okay? But this here is not enough. I'm not going to say it's false. It's just not enough because they're only telling you one side is congruent and the other side is parallel. Well, what about these sides being parallel, and what about these sides being congruent? So you got to have both. You got to have both parallel and both congruent in order to say it's a parallelogram. So that would be choice B, not enough information. All right, this one here, in the diagram below, triangle ABC has coordinates 1, 1, 4, 1, 4, 5. Graph and label A prime, B prime, C prime, double prime rather, the image after translation 5 units to the right, 2 units up, followed by the reflection over the line y equals 0. So we're going to do this one first. So it's 5 units right, 2 units up. So I'm going to go take point A, for example, 5 units right. 1, 2, 3, 4, 5, and then 2 units up, boom, boom. So there is A prime. Okay. Point B, 1, 2, 3, 4, 5, 1, 2. So there's B prime. And then C, 1, 2, 3, 4, 5, and then 1, 2, up. Okay. So there is C prime. A prime, B prime, C prime. And now reflection over the line y equals 0. The line y equals 0, it's a horizontal line where the y's are 0. That is the x-axis. This is the x-axis, guys. The y equals 0 line is right here. That's the line y equals 0. We're going to reflect over that line. How far away are we? We're 3 units away. I'm going to switch colors. We're 3 units away, so we're going to go 1, 2, 3. 1, 2, 3. And this one's 1, 2, 3. This is 7 units away. 1, 2, 3. 1, 2, 3, 4. And there it is. So I have C double prime, B double prime, A double prime. That is my answer right there. A double prime, B double prime, C double prime. All right, so number 8, as graphed on the set of axes below, A prime, B prime, C prime is the image of triangle ABC after a sequence of transformations. Are the triangles congruent? It's asking. Are the triangles congruent? And use rigid motions to explain your answer. Rigid motions, guys, are reflections, rotations, translations. I gotta use reflections, that's a rotation, a reflection, or translation if I'm going to say that they are rigid motions, that they are congruent. Well, if you reflect over the y-axis, you're going to have, boom, 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 1, 2, 3. You're going to have this triangle here if you reflect over the y-axis. See that? And then, how do you get up? You just move it up. It's a translation. So if the triangle just flips and then slides up, those are rigid motions. So we're going to say yes. We're going to say yes because BC, because there was a actually I did it reverse. It goes, this is the image. So we started here, sorry. So we start here, we go to here. So starting here, we did the translation first. So there was a translation followed by a reflection over the x-axis. I'm sorry, over the y-axis. And you would say these are both rigid motions. And you would say distance is preserved. Distance is always preserved. Distance is always preserved for rigid motions. So anytime you have rigid motions, distance is preserved. If you could show the rigid motions, you can explain that they must be congruent. Triangle MNP is the image of triangle JKL after a 120-degree counterclockwise rotation. Again, it doesn't matter that it's 120. The point is it's a rotation, which is a rigid motion. So if it's a rigid motion, you're going to have congruent triangles. So if angle L is 47, if that's 47, and N is 57, okay, so if it rotates around that point right there, J is going to M, K is going to N, and L is going to P. All right, it should probably change colors, right? L is going to P, and K is going to N. See how that goes? See how it rotates around there? And then we'll make the point, this point right here just black again. All right, so blue goes to blue, red goes to red, green goes to green. If you rotate your paper, you'll see that. So 47, this is going to match up with this one. So this is going to be 47. All right, this one, red, matches up with this one. So this is 57. And then three angles of a triangle add up to 180. So 57 and 47 is 104. And then 180 minus 104 is 76. So I know this angle is 76. And let's answer my question. Find the measure of angle M. Measure of angle M is 76. And we just showed why. Okay? Rotation does not change the angles. The angle measures stay the same. Explain how you arrived at your... to explain it, you would say rotations, I'm missing an I, are rigid motions, and angle measure is preserved. Angle measure is preserved. Means it stays the same. Okay, so when you do rotations, the angle measures don't change. So it's just congruent. They're just congruent triangles, guys. Just congruent triangles. But just the language you want to use when you explain. A couple proofs here. All right, so this one here. So we're going to do statements and reasons, right? Statements. I'm going to have to do it like this. I have to do statements. Kind of do on either side of the... and then reasons over here, just because of the room I gave you. Obviously, you wouldn't normally do that. All right, so obviously you got your givens. I'm not going to waste time in the video writing the givens, guys, so we're just going to write the givens. Well, all it is well, you got to write the givens. You got to write MH, congruent. These are your givens right here. So these are going to be right in here. So I'm just going to say givens, but you would actually write them out. You wouldn't write givens on your test, right? Okay, so we are given what? MH is congruent. This right here is congruent to AH. Okay, so we have this is congruent to this. All right, and we're trying to prove angle MBA right here. This is congruent to ATM right there. Okay, so what we're actually trying to do here is we are trying to prove, I'm going to highlight the triangles we're trying to get. It's this triangle here, okay, congruent to this triangle. We have Christmas colors. Okay, those are the two triangles we're trying to get. All right, so I'm going to draw those triangles. I'm going to draw one over here. Do the green one over here. Okay. And I'm going to do the red one over here. It's important that you separate the triangles when they're overlapping. All right, so now, see how this long, why was this long side congruent to this long side? This was congruent to this because the big triangle is isosceles, guys. The big triangle is isosceles. So this angle is congruent to this angle, which is this angle and this angle in the triangles we're trying to get. Okay, that's an important part of the proof. So it's angle, I erased all my letters, right? So we have to say this angle is congruent to this angle. Angle BMA is congruent to angle TAM, and that's because of the isosceles definition of isosceles triangle theorem. All right. Now we got medians. Actually, let's do this first. We got the shared side, MA. MA is congruent to MA, and that's a reflexive property. I'll just put reflexive. You should write reflexive property. So we have this congruent to this. And then the last thing we have is from the medians, right? If AB and MT are medians, okay, we could say MB is congruent to BH. MB is congruent to BH. And we could say AT is congruent to TH. AT is congruent to TH. And that would be definition of median. Okay, definition of median. Now, we want, though, so we got MB congruent to BH. We got HT congruent to AT. All right? But think about that. So those little pieces are congruent to each other. But aren't the big pieces congruent as well? The big side, the AH and the MH? Okay, so if you think about that, so I have this whole side congruent to this whole side, and I have this piece congruent to this piece, and I have this congruent to this. That mean all the pieces are congruent? Because if the wholes are congruent, don't the halves have to be congruent? Okay, so that's what we're going to say. We're going to say MB is congruent to AT And the reason is, and we haven't really used this one before, so you probably didn't get this, halves of congruent segments are congruent. Halves of congruent segments are congruent, okay? They are both halves. So now we have all of them should get double hash marks. So now we got it. We got side, angle, side. So we have triangle, BMA, congruent to triangle, it'd be TMA, and that would be by side, angle, side, side, angle, side. So because we have this now, oh no, we have this and this. Sorry, we don't have that. We have one side, angle, side, side, angle, side, and then angle MBA is congruent to angle ATM, and that's CPCTC. Okay? So once you have because that was the corresponding parts, MBA, that was boom, boom, boom. That's this one here, and that one there, and that one there are now congruent. Those are corresponding parts of the congruent triangles. Okay? So we have that one there. All right, for number 11 here, clear this off a little bit. Now this one's more like something you'll need to do. That number 10 was a little rough. I don't think won't have to do something that crazy on the exam, on your quiz, I mean. But who knows what you'll get on your exam. But yeah, so this one here is a little more manageable. CA is congruent to CB. I think we get that. All right, so I'm going to do statements and reasons, right? Statements, reasons. Okay. Angle 1 is congruent to angle 2. So that's good. Now, if CA is congruent to CB, and angle 1 is congruent to angle 2, if CA is congruent to CB, we also know angle A is congruent to angle B, because, again, if you look at the big triangle, ignoring these lines in here, if this side's congruent to this side, this angle is congruent to that angle. That's the isosceles triangle theorem. So 1, CA is congruent to CB. Angle 1 is congruent to angle 2, and that's given. Okay, and then number 2, we're going to say angle A is congruent to angle B. Can't write today. And that's the isosceles triangle theorem. And because if you look at these little triangles here, I have angle side angle now. So I have triangle ACD is congruent to triangle BCE, and that's by angle side angle. So then, because of CPCTC, I have this side congruent to this side now. I have DC congruent to EC, and that's again CPCTC. And then since I have the sides congruent, that means that angle 3 must be congruent to angle 4. Angle 3 is congruent to angle 4, and that is because again of the isosceles triangle theorem. So we actually use the isosceles triangle theorem twice. When you have congruent sides, the opposite angles are congruent. We used it once to get the angles for the congruent triangles, then we used it again to get our proof statement. Angle 3 is congruent to angle 4. It's more like something you'll need to do on the quiz. Now, this one's a construction. You want to construct the median to AB, guys. So the median is basically finding the midpoint. The midpoint is found by doing the perpendicular bisector. So you're going to put your compass point on A. And I know you don't have a compass with you. If you have a compass, that's great. If not, you just have to freehand this. Put your compass point on A. Remember, more than halfway, and do the do the arc, right? And then put your compass point on B and do your arc. Oh, that was terrible. That was a terrible even freehand, right? Okay. And do your arc, and then wherever, when you line that up right there, wherever it hits is your midpoint. Okay. And then once you get your midpoint, you connect your midpoint with a straight edge. You connect your midpoint to the opposite vertex right there. So that was awful, obviously, but hopefully you did it with a compass and a straight edge and in class. Okay, not really good to do on video there. And then 13, last one here. Triangle ABC has coordinates -1, 4, 3, 7, and 5, 1. So we're going to graph that. You would just put this on your graph. Okay. So -1, 4, 3, 7, and 5, 1. Negative 1, 4. Let me put that on here. -1, 4, 3, 7, and 5, 1. What happened to this graph? I can't even do this. I can't. 1, 2, 3. Is this 4? I don't even know. 3, 7. 5, 1. Okay, so something like that. Alright, so what they want you to do is a rotation of a reflection in the x-axis. So the first thing you do is the reflection. You do this first. So reflect over the x-axis. That's going to be boom. And that's going to be 1, 2, 3, 4, 5, 6, 7. I hope I'm doing this right. And 1, 2, 3, 1, 2, 3, 4. And then you have to rotate 90. Okay, so this is 1, 2, 3, 4, 5, down 1. So we're going to go 1, 1, 2, 3, 4, 5. I'm going to change colors. And then this is 1, 1, 2, 3, 4. So we're going to go 1, 2, 3, 4, 1, 2, 3, 4, 1. And then this one's 1, 2, 3, 1, 2, 3, 4, 7. So we're going to go 1, 2, 3, 4, 5, 6, 7, 4. Pretty sure I made at least one mistake, although it looks pretty good. All right, looks close. Anyways, so here's the original one. This one, right? So that's not part of the. That's just the intermediate step. All right, so here's the original one. Here's the last one. So what does it look like if you just go from the red to the black? What does it look like? It looks like it flipped over. It looks like it flipped over this line, reflected over. See, I did make a mistake there. I think this is supposed to be more like that. That's off by a little bit. Anyways, it looks like it almost kind of flipped over that line, and that's a reflection over the y equals x line. So the single transformation equivalent to this is reflection over the y equals x line. Remember, that diagonal line is the y equals x line. And that is what's going on here. It looks like the red flipped over to the black. And your graph, hopefully, it looks better than that. Mine didn't transfer over to this program very well. So I'll see you for the quiz. Hopefully you got something out of this review, and we'll do well tomorrow.